spanning tree IEEE 802.1d. In Cisco, it is called as per VLAN spanning tree. And also we learned rapid spanning tree yesterday. Whenever you enable rapid spanning tree, make sure you enable port fast on all the access port. Those things you can do in packet tracer, no problem. But this one particular lab, I don't think packet tracer supports. That's why I'm going to use another tool called EVE. So before I enable commands and see how MST works, let's learn first what is MST. MST. Now, earlier, we had some convergence issue in per VLAN spanning tree protocol, as well as in classical spanning tree, which is IEEE 802.1d. In both this protocol, this is Cisco's per VLAN spanning tree. This is industry standard spanning tree. This is simply called a spanning tree because this is going to run only one instant of STP for all VLANs. Whereas here, as the word says, it's per VLAN. For each VLAN, there is a separate instance of spanning tree. And the drawback of this is timer based, so it takes somewhere around 50 seconds and more for the convergence. That's why we enabled rapid spanning tree, which is IEEE 802.1w standard. In rapid spanning tree, we saw it is not a timer based. As soon as some failure happens, the blocking port will be immediately turned to forwarding. So there is no much time taken for convergence. You can say less than 2 seconds, theoretically. It will be much more less than that. Rapid spanning tree is faster. Then why are you going to MST? We had a drawback in this one. So we moved to this one. Why are we now learning another one? Is there any drawback in this rapid spanning tree? It depends on your CPU. You see, it is rapid, fast. Wherever there is a fast, wherever you see fast, definitely there is going to be more consumption of energy. Same way, if I have 100 VLAN, I'm going to have 100 instance of what? I'm going to have 100, sorry. I'm going to have 100 instance of rapid span, which is going to be a high CPU. See? So 100 VLANs, you're going to have 100 instance of rapid spanning tree protocol. I told you whenever you have fast, then processor needs to be more fast. Utilization of CPU is going to be high compared to the earlier PVST P. Compared to PVST-P, CPU is going to be highly utilized. It's like you removed one 80cc engine from your mobile moped and insert 300cc engine. Your moped will be like a bullet now. But the problem is the petrol tank that you had for moped is not sufficient for this bullet. You need a bigger petrol tank because the consumption is going to be more with a bullet engine, 300cc engine. And now, likewise, you have now 100 times 300cc engine, 100 rapid spanning tree if you have 100 VLANs. If I have 200 VLANs, the 200 rapid spanning tree. CPU is going to be utilized. CPU need to be more bigger to support this. If you have big CPU, then don't worry, you don't need MST. You can have this STP. You can have this RS CPU when you have enough CPU. When you have enough CPU, when you have a bigger tank, when you have enough money to fill the tank, why you worry about the petrol consumption? You will never. When you have too much of money and big tank, and if your engine is taking too much of petrol, will you worry? No, you need speed, 300cc. You won't care about how much money the petrol it takes, and how you need a bigger tank. You won't say, "Oh, I am carrying a big tank, 30-liter tank every time in my bike." You won't worry like that because you are interested in going very high speed, and your engine is capable of going in that speed. Your petrol tank is capable of accommodating that many liters of petrol. But when I don't have bigger petrol tank, then problem comes. My 300cc engine is going to consume more petrol, and the bike won't travel for long distance. It will stop after a few kilometers because your tank is not big. What do I mean by that? If your switch is not having enough CPU, rapid spanning tree is not a good one because rapid spanning tree needs more CPU because every single VLAN runs a separate instance of spanning tree, the two rapid spanning tree. To avoid that big usage of CPU, to reduce the utilization of CPU, MST is the solution. MST is the solution. I want to tell you something. When you enable MST, RSTP gets enabled. But the difference is, this RSTP when you enabled, it is rapid spanning tree for each VLAN, per VLAN. For each VLAN, a separate instance of spanning. But MST is rapid spanning tree, only one instant per by default, only one instant number 0 for all VLANs. For all VLANs, you're going to have only one instance of STP.
Yeah, how can that be possible?
Why not? The same CPU, same instant is going to take responsibility of all VLANs. That's all. That is how this IEEE 802.1d is. But in Cisco, we don't have this. We have a modified version called PVSTP, running each VLAN a separate instance. But the industry standard STP is only one instance for all VLANs. It's not VLAN based. Now, when you enable MST, rapid spanning tree is enabled, but not per VLAN. It is by default only one instance. Instance number is 0, to which all the VLANs, say for example, you have VLAN 1 to 100 VLAN. For all the VLANs, this is the only instance that is taking care of loop prevention. That's the job of STP, right? STP has to prevent loop. If there is a break in the primary path, it has to put the traffic in the backup path by making the standby link as a active link. That is rapid spanning. That's the job of spanning tree. So what I'm trying to say here is MST allows you to define the number of instances. For example, when I have this topology which we saw earlier, and 100 VLANs I have, 1 to 100. And if I want VLAN 1 to 50 to be root here, root switch, and here 51 to 100, this to be a root switch. Why? So that for 51 to 100, for 51 to 100, there will be a block here. For 1 to 50, there will be a block here. So how many instances of spanning tree I need? Just 2 instance. Just 2 instance is enough. I'll map instant number 1 to VLAN 1 to 50. I'll map instant number 2, 51 to 100. And I'll set priority 0 for instant number 1. And for instant number 2, I'll put priority 0 here. If the priority is 0, that is going to be the root switch. So when I say instant 2, what are all VLANs mapped? 50 to 100. So all 50 to 100 will pass through this way. And all 1 to 50 will pass through this way. And the two rapidly convergence. If something goes wrong with this link, the blue will also pass through this very fast. Okay, so MST allows you to define the number of instances that you want to have. I need only 2 instances. Even though there are 100 VLANs, I need only 2 instances to achieve this load sharing. If I have only 1 instance, you cannot do this load sharing. Yeah? A question, please. Please ask question. Santosh, are you clear with what I'm explaining? See, between the switches, we need trunk.
Okay.
So what I'll do, I'll go to the middle switch and make it as trunk on this 2 link. sorry, yeah, to a link. So automatically the other end of the links will become trunk through auto negotiation. I showed you this in the previous class. In more detail, I'll be teaching you in another class. Interface range Ethernet 0/0-1. I am right now inside this 2 interface of switch 2, E00 and Z0. Switch port trunk encapsulation .1q. This is one of the protocol that trunk uses to encapsulate the VLAN IDs. And then I say switch port mode trunk. Whereas in the packet tracer, you don't need to type this command. In packet tracer simulator, even if you type this, it will accept. But in this version of there's a real switch image. This particular version needs this command. Only then it will accept this mode command. Okay, next is we'll go to switch 4. Switch port, you see, I say switch port mode trunk, it won't accept. But after I say switch port trunk encapsulation .1q, if I say switch port mode trunk, it will accept. Alright, right now it is trunking on all 4 switches, even though we configure on 2 switches, the other end of the wire is going to become trunk through negotiation. You can go go and verify that in switch 1. Show interface trunk. You see, right now you don't have much VLAN, you just got only the default VLAN called 1. And switch 1 says I'm trunking on these 2 and negotiation. I'm sorry, come again.
Active VLAN remains
We'll
one
talk about the
version.
native VLAN later. Native VLAN is not the topic. Default VLAN is different from native
So
VLAN. We
the
do not
native
focus
VLAN
on this
is
now.
given 1 versus
We have not
1.
spoken about this anywhere so far. Default VLAN is different. Native VLAN is different. You see,
Okay.
show VLAN brief. Where is the
Okay,
things?
sir. Okay.
This is default VLAN. This is different from native VLAN. They are different. So if someone is asking an interview about native VLAN, do not assume that they are talking about default VLAN. Even VLAN 10 can be a native VLAN, but default VLAN cannot be 10. Default VLAN is always 1. Default VLAN is always 1. But VLAN 10 can be a native VLAN. They both are not same. Default VLAN and native VLAN term is not same. Okay, now what is next? I would like to create 100 VLAN on all these 4. Okay, let's not take 100 VLAN. That will be crazy.
Okay.
So let me create 10 VLANs. You see, I can create 10 VLAN in one go because it's a real operating system. VLAN 1-10. Boom. All 10 VLANs created. You want to verify? Show VLAN brief. Look at this. Likewise, I would like to go create on switch 2, 3, and 4. You see, before creating, let me show you show VLAN brief. You don't have VLAN 2 to 10. I'm going to say VLAN 2-10. Show VLAN brief created. VLAN 2 to 10. In packet traces, the hyphen won't work. You need to create one after the other. Okay, we have configured 10 VLANs on each switch. If I type now, you see, show spanning tree, you will see a big page of list of, you see, for VLAN 1 and for VLAN 2, there's a separate instance, for VLAN 3, for VLAN 4, VLAN 5, 6, 7, 8, 9, 10. Separate, which is not good. That's why we want to enable MST. Let me enable MST from switch number 1. Config T, MST, sorry, spanning tree, mode MST. Okay, now I'm going to paste the same command on other 3 switch. All right. Done. Now, what is next? WR is write to memory. I'm just saving the configuration by typing WR. We all know that. Now let us check the same command, show spanning tree, show spanning tree. Look at this, look at this, look at this. Look at this. Only one protocol and one instant. For all VLAN, MST0 is responsible. 0 is the instant number. You don't have for VLAN 10, no. It's the same instant 0 responding you. For VLAN 8, it's the same MST0 responding you. You understand? It's single instance, not separate for each VLAN. You can also type this command, show spanning tree detail. When you type show spanning tree detail, you can see MST is working. MST is working on Ethernet 0, Ethernet 01. These are the two things we have. All right, now what I want to say here is you don't have more instance to consume CPU, it's less. What is next? Next is, let us see where it is blocking. Show spanning tree, no blocking here. Let's check and switch to. Yeah, here's the block. Switch 3, this down port is blocking, which means all the 10 VLANs, we found that this particular port is blocking, which means all 10 VLAN traffic will go through this way. And how many instances of spanning tree? Only one. If I want to load share like 1 to 5 upper path, 6 to 10 below path, then I need 2 instant, and I'll make instant 1 responsible for this 5 VLAN, and I'll give priority 0. Instant 2 responsible for this, and I'll give priority 0 for instant 2. That's the plan. Let me show you step by step. You see, switch 1, show MST configuration. Show spanning tree MST configuration. You can see right now for all VLAN, only one instant, only one instant, only one instant. I told you the default number of instant by default is only one. Now, if you want to create more than one, then you need to follow this procedure. It will be slightly difficult. Not difficult, let's follow. You see, spanning tree, MST configuration. So you will be inside the MST mode and you need to say, you see, name. Name of this configuration, what do you want to give? I want to give like my MST, some name. And you see the revision number. What is this revision number? Whenever you do some changes to the MST database, if you want the change to impact, then you have to increase the revision number. If the revision number is not incremented, your changes won't impact. So I'm going to first of all say revision number 1, which means I'm going to do some changes and that change should impact. And now instance 1 for VLAN 1 to 5. Instance 2 for VLAN 6 to 10. That's it. Let's verify. Show spanning tree MST configuration. Look at this. You have 3 instance, the default instance 0, which is no more having 1 to 10. Earlier it was having 1 to 4094. Now instance 1 which I created takes responsibility for this, and instance 2 takes responsibility for this. So what are we going to do? We're going to copy this configuration and paste it on all the other switches. Show run will show you all that I configured. This is what I'm going to paste. I'm going to put this on all switches. Switch 2, switch 3, and switch 4. After this, let me take you again to switch 3. Show spanning tree. You can see there will be 3 instance. Instance 0 don't mind because those VLANs we don't care. Instance 1 we do care. For VLAN 1 to 5 this is responsible. See, for VLAN 1 to 5 it is blocking. And MST2 also it is blocking 6 to 10. You can type here now MST1 and it says very clearly MST1 it is mapped to these VLANs only. And it is blocking. Right, and MST2 blocking. Now we do not want this, only the upper path. See, right now only the upper path is used because both for MST instance 1 and 2 this is blocking. We want to change the story. How? As I said here, instance 1 I'm going to say priority 0 here. Instance 2 I'm going to say priority 0 here. Let's do it. And do you follow? So far good? Okay. Now I'm on switch 2, spanning tree MST 1 priority 0. On switch 4, spanning tree MST 2 priority 0.
Yes, sir.
As a result, you will see different story now. Let's go check. Right now, switch 4 is the root switch for MST2. How do I know that? Verify. Show spanning tree MST2. You can see that this is the root switch for VLAN 6 to 10. Both are forwarding. Let's go to check on switch 2. Show spanning tree for MST1. Here the same story for VLAN 1 to M forwarding. What about MST2? MST2 switch 2 is blocking. MST2 switch 2 is blocking. MST2 switch 2 is blocking here. MST2, it's blocking here, which means VLAN 6 to 10 will not pass through this way. It passes through the below part. Go to switch 4 and verify one more time. It's here, forwarding. Whereas on switch 4 for MST1, it is blocking. VLAN 1 to 5, switch 4 is blocking. This guy is blocking for MST. So you can see load has been shared.
Below.
VLAN 6 to 10 goes this way. VLAN 1 to 5 goes this way with the same advantage of RSTP. What advantage? Fast conversion. All right, that's the story of overall story, the complete story of spanning tree protocol. The spanning tree protocol topic has come to an end. In our next class, we are going to learn about how the trunk negotiation happens, the trunk negotiation protocol, access port, dynamic desirable port, trunk port, auto mode, dynamic auto, so on. We stop here today. Any question before we close? All right.
No, sir. Fine.